Hi learners, welcome to my YouTube channel. So today we'll do the part 2 of the same topic, that is the congruent triangles. So we'll see the exercise 15.2. So here, which of the following pairs of triangles are congruent, and you have to name the test of congruency and write the correct order of correspondence. So now we can see this is the figure given, these figures are given here it was given in the book, I have pasted it here. So now here, this will be this A, B, C, and F. They are congruent. I'll show you how. Now see here, this is the side and this one. So we can see here two lines. So this side is common. That is congruent. So now this one be this and this one. So this angle is same. So now this and this means this side is same. So these two triangles are congruent. Now we can look here. So now we can see XY. So you can see here one line, and here we can see this one line. So it need not be here. So even here, because you can see along with that there are two angles here. So this side and this side again here, and because this side is this one same, so you can see the angle over here means this both can be. So don't get confused why this is on the right hand side and this is not. So even because you can see that you can compare the angles as well. So this angle is along with this one. So these both angles are here, and this side means both are the same. So this is congruent. Now you can see this is divided into two triangles, 1 and 2. So BD, side is equal to this DC. So this is congruent. Here you can see here, these are the angles common. These and these are same. But you can see this side is here at the base and this is at the side, so this is not possible. Now here you can see this side and this side is same, this side and this side is same, this angle and this side is angle, this same. But we can see here this is side angle. We don't have any test over this one congruency, that is SSA. We have SAS, ASS, SSS. So this is not. Now you can see here this and this one. So now this side is equal to this one, this side is equal to this one. So this is congruent, and these both triangles are of the same shape. So here it is written here for the first one, for A, XYZ is congruent to CAB. See here, because this you are going this way, XYZ, and these are the congruencies. So you have to go this also this way, that will be CAB. And what is here? Side, and then middle comes the angle, and then the side, SAS. Again for this one, the B, what we can do here, we can go this way, X, Y, Z. And here you are going to go this way because we have the congruent side over here. So you cannot go this way because since you went for this way, you cannot go this way. So now see here, X, Y, Z, and this will be ACB. So X, Y, Z and ACB. So how is that going to be? This is angle, then side and angle. So ASA. Now for the C1, we can see here, ADB is equal to ADC, this one. So what we have the side, then the middle one, because here is nothing means there will be 90 degree, that will be an angle, and this is again a side. So that is SAS, side, angle, side. Now for the F, what we can do here, we can see this, all the sides. So this is one, suppose the triangle. So this is a common for both of them. So side, side, side. So that is going to be ABC. If you are going this way, this also should be, we have to go this here. That is going to be DBC. ABC and this one. Hope this is clear. So that is SSS. Now to prove ABC is congruent to PQR by RHS test of congruency, what additional information is required? So these two are given. So what we can see here, now this is AB, because this AB is equal to PQR. So now what we can see here, what additional information is required? So now we have for the RHS this one. So now they have given this side is equal to this one. So we need the additional, that is that AC should be equal, because this is the hypotenuse, because we know this is a right triangle. So this is the hypotenuse side. So AC is the hypotenuse one. So same for this one. This is this one. So if we know for RHS, because this and this sides is going to be the same. So now here AC, you need additional, what additional information that should be given, that AC is equal to PR. So this should be additional. In the adjoining figure, prove that triangle ABO, that is ABO, so is equal to triangle P, sorry, it will be PQO. So this one. So now we have to prove this one. So now what we have, they are given here. So now this will be, now the AB is equal to, because they said this is congruent, so AB is going to be is equal to PQ. So why is that so? Because these are the sides. So there we can say corresponding, because these are the corresponding sides are equal. Then they have given this is equal to this, that BO is equal to QO. So corresponding sides are equal. You have to write the reason for that. So we can say angle ABO. Can you see here? Because this is the angle given. This is angle ABO is equal to PQO, because this angle is given. So we have to look at the middle one. Whenever we write PQO, so the middle one we have to consider. So this is that one. And there, whenever we write ABO, the middle one. So ABO is equal to angle PQO. Why? That is the corresponding angles. These are the angles are equal. So we want, whenever these are equal, means that means triangle ABO is congruent to triangle PQO. So how it is going to be? So this is going to be angle, then it is going to be a side, and then again a angle. So it is going to be ASA congruence. In the following problems, choose the criterion SSS, SAS, ASA, AS, and RHS to establish the congruence of given triangles based upon the information given in each problem. If there is not enough information to prove the triangles congruent, so here choose not possible, that is NP. So these are this given. We can see for this first one, given AB is equal to CB and AD is equal to CD, and we have to prove triangle ABD, this one ABD is equal to, that is CBD. So now here they are given AD is equal to CD, so we are, that is given. AB is equal to CB, that is also given. So now what we can see for both these triangles is BD is common, right? So we can write here BD is equal to BD, that is common. So now therefore we can say ABD, that is, we have to prove that ABD is congruent to triangle CBD. How it is going to be? Because this also is side, because they said AD and this is CD, so side. Again this AB and this CB, this also is side. So this also is CB, this is also side, that is SSS. Triangle ABC and triangle EDC. Angle 1 is equal to angle 2, and angle A is equal to angle E, and AC is equal to EC. And you have to prove triangle ABC is equal to triangle EDC. So now angle 1 is equal to this one, angle 1 is equal to angle 2, so that is given. Again angle A will be equal to angle E, that also is given. And then this side, AC is equal to EC, that is also given. So here we have, how many angles we have? So we have this two angles. So this one as well as this one, we have two angles, and one is the, this is the, here we have one, the side is given, that is AC is equal to, so we have two angles and one side. So what we can say here, see here, angle and this angle, and this middle is the side. So we can say angle, side, again angle, angle, side, angle. So that is ASA congruence. KT bisects angle IKE, means this is bisecting. So this is the angle, it is bisecting. KT is the bisector. This part is the bisector. So an angle ITE. So this one, it is bisecting this angle. ITE means this angle. Prove triangle KIT is congruent to triangle KET. So given what is that? KT is bisecting angle IKE and angle ITE. That is not angle IKT. So here now we will see this one, angle IKT will be equal to E. So it will be equal to EKT. So this angle is going to be this one. It will be also equal to this one. So the angle ITK is equal to angle ETK. So now you have to prove triangle KIT is congruent to triangle KET. So we'll start with the proof. angle IKT is equal to EKT, as I told you now, this step. So angle IKT is equal to angle, so it will be ITK is equal to angle ETK. ETK. So this is going to be this one. So, and what is given here? KT is equal to KT. As I told you, this KT is equal to KT. So that is common. So here what we can see, here two angles on one side is congruent. So we can say that is ASA congruence. So the next one here, given quadrilateral PQRS, PQ, this stands for the perpendicular. So the PQ, if we are taking this like this, so PQ is perpendicular to this QR. So now what you can see here, and PS is perpendicular to this, PS is perpendicular to this SR, and PQ, this PQ is perpendicular to this QR. So this is perpendicular, this one, that is QR. So now we will see here, we have to prove that triangle PQR is congruent to triangle PSR. So now QR is equal to, this QR is equal to this SR. These both are the same. So PQ is perpendicular to QR. So that is what? Angle PQR. So when we say here PQ is perpendicular this QR, so we can say this whole thing, this PQR, this is going to be 90 degree, because perpendicular means it is always going to be 90 degrees. So PQR, this whole angle means the Q, this is going to be 90 degree. And when they say PS is perpendicular to SR, so PS, yeah, this is PS is perpendicular. So this we're going to take this whole one. So PSR. So this is going to be 90 degree. So now what we can say here, QR is equal to SR. QR is equal to SR, which is given. So we have to prove that triangle PQR, this triangle, is equal to PSR, this triangle. So you have to prove this one. So proof means, now we will start with that. Angle PQR is 90, that is given. Angle, this one, angle PSR, that is also 90, which is given. So we have, from this one, we have tried to form this one. So that is given. And PR, so we can see this PR is equal to PR, that is common. And again QR is equal to SR. So again QR is equal to SR, that is given. So what we can do here, we can say there is right triangles in both the triangles, right? So here we have, these are the right triangles, because this is 90 degree, means we have right triangle in between these two. So we can say that QR is equal to SR, because the sides are equal, therefore triangle PQR is congruent to triangle PSR by RHS congruence, because in RHS we have that 90 degree. Now here AB is equal to DC and angle A is equal to angle D. You have to prove that triangle ABO is congruent to triangle DCO. So now here AB, this is AB is equal to this DC, and this angle A is equal to angle D. So you have to prove that this will be ABO, this triangle, is equal to DCO, this triangle. So now AB is equal to DC, because why? These are the given things what we are going to write. Corresponding sides are equal. Then angle A is equal to angle D, that also is given. So corresponding angles are equal. And we have to prove that, this is what we have to prove, that ABO is equal to triangle DCO. So we'll start with the proof. Again, we'll start with the given things, that AB is equal to DC given. Angle A is equal to angle D given. And what we can see here, BO. This one BO is equal to, this BO is equal to CO. So that is common for this one, CO for BO and this CO. So that is common. So what we can say, therefore triangle ABO is congruent to triangle DCO by what? AAS. Because the two angles are given and one side is given. So we can say by AAS congruence. M is the midpoint of AB. M is the midpoint. Can you see, this is AB, this is then, so M is in the middle of it. So M is the midpoint of AB. And then AC and BD are perpendicular. So this and AC and this BD, they are the perpendicular. This is the perpendicular to what? To this CD. This CD is for both of them. So we have to prove that triangle ACM. So ACM, this triangle, is equal to BDM, this triangle. So now given is what? M is midpoint of AB. That will be what? If M is midpoint of AB means AM will be equal to this BM. So that is AM is equal to BM. And what? AC and BD. So AC and this BD, they are perpendicular to CD. That is the given things. And we have to prove that triangle ACM is congruent to triangle BDM. So we will start with the proof that AC is perpendicular to CD. So now AC is perpendicular to this AC is perpendicular to this CD. So that will be, so angle ACM will be 90 degree and BD is perpendicular to CD. That is angle BDM is equal to 90 degree and AM is equal to BM. So now you can see here AM is equal to BM. So that is why, that is since M is midpoint of AB. So now CM is equal to DM. Since why? We can also put a bracket over here. Since C and D lie on same line CD, you can just have a look at the diagram. Therefore, ACM is congruent to triangle BDM, but that is by RHS congruence. So RHS means here why? Because these both are 90 degrees, so that will be RHS congruence. Now prove that triangle PQR is congruent to triangle STU and find the measure of angles X and Y. So now these are the diagram, this figure is given. So now you can see this, here is PQ. And here is ST. So can you see single line means this, though both the sides are congruent. So we can say PQ is equal to this one, or we can also write here congruent is ST. So now we can see here these two lines and here two lines means this will be QR is equal to this TU. So QR is equal to 2. That's why we have to write that is the corresponding sides are equal. Here also corresponding sides are equal. Then what we can see, this angle, this Q is equal to this T. So corresponding angles are equal. So now here, or also we can include one thing, this PR is equal to this SU also, because these are three lines means PR is this one because they are the corresponding sides. So now you can see this Q is equal to T and this will be, R will be equal to U. So now again I'll repeat, this Q will be equal to T and this R is going to be equal to this U. So now let us start to prove what we can. First let us prove this one. Triangle PQR is congruent to triangle STU. And then we will start with the proof, that is PQ is equal to ST, which is given. PQ is equal to ST, which is given. Then what we can see, angle Q is equal to angle T. The angle QR is, the side QR is equal to TU, which is also given, that we have seen. Therefore, we can say PQR is congruent to triangle STU by what? Because now you can see this is side, then is angle, and then is side. So we can say SAS congruence. So now we can see here angle Q, because now can you see here angle Q, they have said to find the value of X and Y. So angle Q is equal to angle T. So what we can take, X minus 5 is equal to 45. So we can solve this first. Angle Q means this is X minus 5 is equal to 45. So when you solve this, X minus 5 is equal to 45, X will be what? 45, and this you take on the side, that is going to be plus 5. So X will be 50 degree. So now what will you do? You will take this and this one. So what is that? Angle R is equal to angle U. So Y plus 9 is equal to 27. Or we can write 27 is equal to Y plus 9. So R is equal to angle U. So 27 is equal to Y plus 9. So what we can do, this 27 will remove the bracket. So when you take this plus 9 on this side, that is going to be minus 9. So that is Y. So this will be 18 will be Y. So we got the values of X and Y. So X is 50. You can write it separately if you want. X is 50 degree and Y is 18 degree. Now the next one, which of the following triangles is congruent to the adjoining ABC? Now these are the triangles given, and this is that is given, the adjoining figure is given, that is ABC. So now what we can do, this side we can see this is 7 and this is 5, and then the angle is 70. So where you can see a similar one. Now see here, this angle is 70 and here is 7 and here is 5. So here other things what you can do, see in this case here was 70, but opposite to that, now if you go opposite to this one angle, here this is, we don't know the measurement of this one, but if you go to opposite of this one, here is 8 and 5 means this cannot be. If you go to opposite to this one, this is 80, so this is 70, so this is 80, so definitely this cannot be. But then if you go to opposite side, this side is blank and here is 7 and here is, so on the blank side the other side is 7 and there is 5, so this matches. And now if you go to this 70, if you go on this one is 7, so definitely this cannot be. So you can just consider this 70 and then accordingly decide it. In the adjoining figure, which of the following is correct? Now look at here. So here you have to be very attentive. Now see, this is 35 and this also is 35. So here is 6 and here also is 6. So they said PQR is equal to triangle RSP. So PQR, if you go this way, PQR, if you are going this way, is equal to RSP. RSP. So yes, whatever is here, this will be here. Whatever is here, it is here on the opposite side. So this can be. Otherwise, I just check for this one. See if it is PQR. And this is given as SRP. So S, R and P. So here what we can see here, it doesn't match with the angles because S is here and then R and then P. So here whatever was there is not here, because when you take this one, this is the angle for this one, and when you take like this, so this is the angle for this. So whatever you have 35, it should be here 35. So this is definitely not. Again for RPS, RPS also RPS. So whatever is here, it should be here, which is not. And so yeah, PQR, sorry, this should be here. This side PQR is equal to this one, so it should be here. Whatever is here should be here, which is not. Again SPR also, so you can check with this one, different one. So only the possibility is A. So by this one we have completed today's work. Do like and subscribe to my channel so you get a notification of other parts. Thank you.